Welcome everyone. This is the first chapter on Calculus 1, Math 201. We are going to start with the first unit. It is chapter 2 on your textbook, and the name of the chapter is Limit and Continuity. We are going to start with this concept here, which is called the average velocity. So because we'll be using calculus in physics, we'll be talking about a lot of things related to physics. So the first thing that we are talking here is called the average velocity. So let's find out how we can find the average velocity for a particle moving along the curve y equal to f of x. So we are considering that a particle is moving along this curve. So we can draw that to represent. So let me draw the representation for that. Suppose I have this y-axis here, and then I have the x-axis here. Along the x-axis, I have the x value, which is like time. And along the y-axis, I have the function value f of x, that is the position. So what I'm about to draw here is the graph of the function y equal to f of x, which is also called the position function. Suppose the graph of the function is something like this. Suppose this is the graph of the function y equal to f of x. Okay, that is my function y equal to f of x. Now we want to find the average velocity of the particle on the interval from a through b. The particle is moving along this curve. So when x is equal to a, some value here, when x equal to a, suppose this is x equal to a, and here suppose that is x equal to b. So when x is equal to a, the position of the particle will be this one. Here is the particle on the graph. The particle will be here on the graph when x is equal to a. And when the time is increasing, when time is b, the particle will be somewhere up there. So when it is b, the particle is here at this position. Now, if you want to write the coordinate of this point, your x value is a. So x value is a, and the y value is the value of the function at a, which is f of a. So this is a comma f of a. And this point here, your x value is b, so that is b comma, value of the function is f of b. So you have 2 points here and here. If you want to find the average velocity of the particle between these two time periods from a to b, the average velocity is given by this formula here. V average, okay, V sub AV, that is average, is equal to f of b minus f of a over b minus a. Now, if you look at this very carefully, when you look at this formula carefully, f of b minus f of a, this is this one, f of b minus f of a, that is change in y coordinate. This is like y2 minus y1 divided by b minus a, that is change in x coordinate, that is x2 minus x1. That means if you look at this very carefully, this is change in y over change in x. And you know that the change in y over change in x is the slope. That means the average velocity measures the slope of the secant line joining these 2 points, So when we talk about the average velocity, it is nothing but the slope of this line here. Okay, slope of that secant line. So you can say average velocity, you may also add this to your note catcher. So V average is slope of this line, is slope of secant line, slope of secant line. So on the first part of the chapter, we are going to learn how to calculate the average velocity. Always remember, average velocity is the slope of the secant line. Now here is the example based on the theory that we have just discussed, that is the average velocity. So the question here is, suppose a particle is moving along a curve, f of x equal to negative 4.9 x squared plus 30x plus 20. We have to compute the average velocity of the particle on the following intervals. For the first part, we have to find the average velocity between 2 and 4. And for the second part, we have to find the average velocity between 3 and 5. So let's work on the first part, part A. So what we know is, when you're working on this, what we know is if you want to find the average velocity, we have just discussed that average velocity is f of b minus f of a. So this is like a comma b. So in place of b, I have 4. So it will be f of 4 minus f of a. In place of a, I have 2 divided by b minus a, which is 4 minus 2. That's b minus a, 4 minus 2. 4 minus 2. So now let's see how we can do this. First, we need the value of f of 4. And in order to find the value of f of 4, meaning of f of 4 is we plug in 4 to this function. So you can do the side work there. We can always do the side work. So let me do that. F of 4. F of 4 will be, you plug in 4 there. So negative 4.9 times 4 is squared plus 30 times 4 plus 20, which is equal to, you can use your calculator to simplify this, negative 4.9 parenthesis 4 is squared plus 30 times 4 plus 20. If you simplify that, using calculator, you should get 61.6. Make sure you check that. So f of 4 is 61.6. So let me write that value, 61.6. Then we have minus, then I need f of 2. So in order to find f of 2, again, I need to plug in there 2. So let's do that. F of 2 will be negative 4.9 times 2 squared plus 30 times 2 plus 20. So if you simplify this using calculator, negative 4.9 parenthesis 2 squared plus 30 times parenthesis 2 plus 20 in our calculator, I got 60.4. This is 60.4. So f of 2 is 60.4. Let me write that value, 60.4. Divided by, in the denominator, I have 4 minus 2, which is 2. So that is equal to 61.6 minus 60.4. If you perform that subtraction, that is 1.2 divided by 2, which is equal to 1.2 divided by 2 is 0.6. 0.6. So that is the average velocity. Average velocity between 2 and 4 is 0.6. In part B, we have to find the average velocity between 3 and 5. So in place of A, you have 3. In place of B, you have 5. So the average velocity, we can write the formula. V average is equal to f of B minus f of A. That is f of 5 minus f of 3. F of 5, you can see there. Let me write it. F of 5 minus f of 3 divided by b minus a, that is 5 minus 3. 5 minus 3. Now, we need to find what is f of 5 and what is f of 3. So in order to find f of 5 and f of 3, we plug in here again. So let's do that. First, f of 5. You plug in 5 there. So negative 4.9 times 5 squared plus 30 times 5 plus 20. If we use our calculator to simplify that, here I'm using it and I got 47.5. 47.5. Similarly, I need to find f of 3. Let's find that one too. F of 3 is equal to negative 4.9, plug in 3, so 3 squared plus 30 times 3 plus 20. If we simplify this using calculator, we should get 65.9. So we can plug in those values here to get the average velocity. F of 5, we got the value. It is 47.5. 47.5 minus f of 3, we got the value here, which is 65.9. 65.9 divided by, in the denominator, I have 5 minus 3, which is 2. So 2 in the denominator. Now the difference between 47.5 and 65.9 is negative 18.4 divided by 2. And if we divide this, negative 18.4 divided by 2 is negative 9.2. Negative 9.2. So negative 9.2 is the average velocity for part B. Okay, now I'm going to show you how to calculate the average velocity directly in our calculator. You can also follow along with me. All you have to do is go to y equal to, then type in the function. Our function was negative 4.9 x squared plus 30x plus 20. Now, in order to exit this screen by saving the function there, you press second in mode. If you press second in mode, you can exit it quickly. If you look at part A, you have f of 4 minus f of 2 divided by 4 minus 2. So in the numerator, we have f of 4 minus f of 2, but our f is y. We stored the function in y1. You can go back and check. We stored the function in y1. So what we do is, after we open the parenthesis, we are typing the numerator. We go to second. We go to second and then trace. Hold on, not second and trace. Just give me a second. It should be alpha and trace. If you do alpha and trace, it will bring the list of function. Our function is in 1. It's y1. So hit enter. So the first one was the value of the function at 4. So this is like f of 4, parenthesis 4, f of 4. Then we have minus, we have f of 2, again, alpha, trace, and enter. That's your f because our function is y1 at 2. So that's your 2. And then close the parenthesis. So this parenthesis and this one is for numerator. Then this division sign is for denominator. Now type everything in the denominator inside a parenthesis. So parenthesis begin. Inside the denominator, or in denominator, we have 4 minus 2. Close the parenthesis. So this first parenthesis is for the numerator. Everything in the numerator is there. Divided by, this is what we have in denominator. If you look at the answer to the first part, we got 0.6. Hit enter, 0.6, there we go. So that is the quick way of doing it. So if you know how to use calculator, you can do it quickly like this. Let me show you the second part. In second part, we have f of 5 minus f of 3 over 5 minus 3. You can also follow along with me in your calculator. Parenthesis begin, alpha trace, we have 5, then minus, again we do alpha trace to get that function. We have a 3, close the parenthesis to end the denominator, divide for the fraction bar. In the denominator inside the parenthesis, we type 5 minus 3. 5 minus 3, we close it. We got the answer as negative 9.2. Let's enter and check it. See, negative 9.2. So this is quite interesting. Okay, it's quite easy to use calculator to get those values. Example, find the slope of a secant line joining the points corresponds to x equal to negative 2 and x equal to 4 on the graph of the function y equal to half x squared. So what we are going to do is, let's draw the graph of this function y equal to half x squared. If you can draw it without using calculator, that's wonderful. If you need help of calculator, you can also do that. I'm going to draw without using calculator. Suppose that is my y-axis. Here is my x-axis. So that is x-axis and y-axis. Now we need to draw the graph of that function, which is y equal to half x squared. So it's an upward facing parabola like that. So this is y equal to half x squared. We have to find the slope of the secant line joining the points on the graph at x equal to negative 2 and x equal to 4. So when x is equal to negative 2 should be somewhere here. When x equal to negative 2, the point on the graph is here. So when it is negative 2, the point is somewhere here. So if you want to label that point, your x value is negative 2. Y value will be, if you want to find the y value, you plug in negative 2 here. Negative 2 is squared is 4. and half of 4 is 2. So that point is 2, 2. That is the point corresponding to x equal to -2. And when x equal to 4, x equal to 4 is somewhere here. The corresponding on the graph should be somewhere there. So this is the point when x equal to 4. When x equal to 4, let's find out what is y equal to. So you plug in 4 here. 4 is squared is 16, and half of 16 is 8. So that point there is 4, 8. Now the question is, we have to find the slope of the secant line joining these 2 points. So if you draw the secant line, okay, if you draw a line joining those 2 points, your line will be like this. This is the line. That line is the secant line. And we need to find the slope of this secant line. And you are very good in finding the slope of a line from your college algebra. So whenever you are finding the slope, you know that the slope is denoted by m is equal to change in y value, y2 minus y1, over change in x value, x2 minus x1. So this implies your slope is equal to y2 minus y1, your y2 is 8, y1 is 2. So it is 8 minus 2, 8 minus 2 divided by change in x, 4 minus or -2, 4 minus or -2, which is equal to m equal to 8 minus 2 is 6. And then in the denominator, 4 minus a -2, minus a negative is plus. So that is also 4 plus 2, which is 6. So that means the slope of the line is m equal to 1. Slope of the secant line is m equal to 1. So you can clearly see that if you look at this line, when you go from left to right, the line is increasing. It is going up. That means the slope must be positive. We got +1, and that makes perfect sense. Now we are looking at instantaneous velocity. So this is a little bit different from the average velocity. Here also we are going to demonstrate with the graph. So let's draw a graph of the function. Let me start drawing here by drawing the y-axis first, and then the x-axis. Suppose that is my x-axis. So along the x direction, we have the x value or the time. And along the y direction, we have the value of the function or the position function. Now, let me draw the graph of the function y equal to f of x. So I'm going to draw a function y equal to f of x. I don't have any specific function. It can be any random function. So this is my random function. Say, for example, this is y equal to f of x. What we learned so far in instantaneous velocity is this. If you are calculating the average velocity between x equal to a, this is at x equal to a, and x equal to b here, x equal to a and x equal to b, the average velocity is the slope of the secant line. Your average velocity will give you the slope of that line there, which is called the secant line. Now what I'm trying to do is I'm going to move this b closer and closer to a. Okay, I'm moving this b closer and closer to a. So next time, suppose, say that b is in a new position somewhere here. When b is somewhere here in a new position b1, the line, the secant line will be a little bit different. In this case, the secant line will be here. It will go from this point and it is here. You can see that the secant line was here before. When b gets closer to a, the secant line has dropped a little bit. This is my new secant line. If I push this b little further, I'm pushing b little further closer to the point A. Suppose it is here. It is here at B2. In that case, your secant line will be a line connecting to this first point with that second point. So first point with the second point like that. That is the secant line. So this is the secant line S1. This is secant line S2. This is secant line S3. And what we are seeing here is by doing this, this distance between A and B was this much in the beginning. Now it is reduced to that. Now it is still reduced to this. So this distance between A and B, we want to make this very small. We want to make this distance very small. We want to make it very small. How small? Very close to 0. Okay, we want to make this distance very small. That means when B is very close to A, then the secant line will be like this. Your secant line will be just like that. Your secant line will be just like that. This line will technically pass through a single point on the curve. It will just pass through this point on the curve, only one point. So this line is no more a secant line. Instead, this will just touch the curve and go. The point is here, and this line is just touching the curve at that point. That means if a line is just touching the curve at a point, the line is called the tangent line. It is called the tangent line. Okay, so when this h is very small, or this distance is very small, which is denoted by h, then we say that the secant line will be tangent line. In that case, when this time interval is very small, the average velocity is now called the instantaneous velocity. We are looking at the velocity just at that point. So for a particle moving along the curve y equal to f of x like this, the instantaneous velocity is given by this function. V instantaneous is equal to f of a plus h. This is the point A on the curve. H is a very small number. For example, if A is 2, then H is like 2.00000 and 1. So very small value. Okay, so f of a plus h minus f of a over h. And we have already seen that when this h is very small, the average velocity, it will be the slope of the tangent line at that point. So that is the fundamental concept. So when we talk about the instantaneous velocity, it is just like the average velocity, but the time interval is very small. That's why we are calculating the instantaneous velocity at a point. And because we are talking at a point on the graph, and also the secant line touches the graph at only one point, now it is called the tangent line. So the instantaneous velocity measures the slope of the tangent at a point x equal to a on it. So that is the theoretical part of the instantaneous velocity. Example, suppose a particle is moving along the curve f of x equal to negative 4.9 x squared plus 30x plus 20. We have to compute the instantaneous velocity of the particle at x equal to 3. So if you remember the formula for instantaneous velocity, let me work on A first. V subs inst, okay, V sub inst, V instantaneous, is equal to, if you remember, this was the formula, instantaneous velocity is equal to f of a plus h minus f of a divided by h. So a is the given point, it is 3. So I need f of 3 plus h. So it will be f of 3 plus 0.00001. So it will be 0.00001. If I add h, that's what it will be. Okay, I'm considering h as 0.00001. Then minus f of a, that is f of 3, divided by h. So our h is this one, 0.00001. 0.00001. So we need to compute this value using calculator. Okay, we need to compute this value using calculator. Let's try that. I'm going to show you my calculator. So here is my function. Now what we are going to do is, in the numerator, we are going to type f of 3.00001. So our function is in y1, so it is alpha trace and then y1. We have 3.00001. Then we have minus f of 3, so alpha, trace, and 1. That's the function value at 3. Close it, that's your numerator. Divided by our denominator is 0.00001 because that's our h. So you can see that the instantaneous velocity is 0.6. So it is approximately 0.6. 0.6 is the instantaneous velocity. Now part B, we have to find the instantaneous velocity again. So we write V sub inst for instantaneous velocity. So we need f of a plus h. In place of a, we have 4.3. So it will be f of, so let me write V inst is already written. So f of 4.3, you can also do this in your calculator if you don't know what exactly you'll get. So you'll do 4.3, then plus 0.00001. Then you'll see that you'll get 4.30001 because we need f of a plus h. So this is my a, and I'm adding h, and I'm always using h as 0.00001. So that's why it will be that much, minus f of a, in place of a, I have 4.3, then divided by h is 0.00001. That's what I'm using. So now we are going to use calculator and find this value. So here we have the function. We come back to the main screen and we type the numerator, which is y1, which is alpha trace, y1 of 4.3, then we have 0.001, close it, then minus, we have f of 4.3, 4.3. So alpha trace y1, here we need 4.3, 4.3, close it, close the parenthesis, so that is the end of the numerator. Then we divide that by the denominator, which is h, or 0.00001, and hit enter. I got negative 12.14. Example, find an equation of line tangent to the curve y equal to natural log x at x equal to 2 on it. So here we want to find the equation of tangent line. What we know is the instantaneous velocity will give you the slope of the tangent line. Once we have the slope, we can easily find the equation. So let's draw the situation here. First, let's draw the graph of the function. Hold on. This is my y-axis. This is my x-axis. If you need help of your calculator, you can definitely do that to draw the graph. But I think the graph of the natural log function will be something like that. So that is the graph of y equal to natural log x. So that is the graph of natural log x. This is x equal to 1. X equal to 1 has the intercept there. Okay, so this one, if you want to know that point, this is when x equal to 1 and y equal to 0. But what we want is we want the tangent line at x equal to 2. So x equal to 1 is this distance, so x equal to 2 will be somewhere here. So the corresponding graph on point on the graph is this. So when x equal to 2, the point on the graph is somewhere there. So this point is x equal to 2. And when x equal to 2, you can clearly see that the corresponding point on the graph is, when you plug in 2, it will be natural log 2. So the y coordinate will be natural log 2. So natural log 2 is the y coordinate. Now, this is the point of contact. We need the equation of tangent line passing through this point. Now, if you draw the equation of tangent line, or if you draw the tangent line first, let's see how the tangent line will look like. If we draw the tangent line, let's find it out. If we draw the tangent line, this is how your tangent line is. It will just pass through that point. You can see it is just touching at that point and it is going down. So clearly what you can see is if you find the equation of this tangent line, when you go from left to right, the slope is positive. It is increasing upward. Slope is positive and y-intercept is negative because it's below the x-axis. So the y-intercept will be negative. So we are going to find the equation of that. This is our x-axis. This is the y-axis. Okay, the point of tangency. Point of tangency is 2 comma natural log 2. That is where the tangent line is on the graph. So we got that. That is the first part. Second, we want to find the slope of this line, which is the instantaneous velocity. So slope of tangent line, slope m is the instantaneous velocity, which is f of a plus h. So it is y of, because our function is y of a plus h. This is my a is 2. So 2 plus h will be 2.00001 minus f of a, that is f of 2, divided by h. Divided by your h is 0.00001. So we are going to use calculator and simplify this one. So here in our calculator, we go to y equal to, we type natural log of x. And then we come back to the main screen. Then in the numerator, we have natural log of 2.00001. Close the parenthesis, minus the value of the function at 2. Okay, close the parenthesis for the numerator, divided by, in the denominator I have 0.0000 and then 1, and hit enter, and it is 0.5. So now we have the point and we have the slope. Once we have the point and the slope, we can easily find the equation. So if you remember how we find the equation from college algebra, when you have the point and the slope, the equation will be, if you remember that equation, it was y minus y1 is equal to m times x minus x1. That is the equation of the line. So x1, y1 is this value. This is your x1. This is your y1. So let's plug in. Y minus your y1 is log 2, natural log 2. Your slope is 0.5 times x minus your x1 is this one, which is 2. x1, y1 is the point. x1, y1 is the point. Okay, m is the slope. Now, let's simplify this. So y minus natural log 2 is equal to, here we have 0.5 times x, which is 0.5x when you distribute that. Okay, 0.5 times x, 0.5x. And 0.5 times 2 is 1. So minus 1. When we write the equation of the line, we write y equal to mx plus b form. So we'll move this to the other side. So we write like this, y equal to, on the other side, I have 0.5x minus 1. Now we have to move this natural log of 2 to the other side. That is, by adding natural log 2 on both sides, it will be plus natural log 2. So y is equal to 0.5x. And here, we can use calculator to simplify this. Here we have natural log 2, ln 2, minus 1. So we can do that part in calculator. It's like natural log 2 minus 1. If we do that in our calculator, you should get negative 0.30685. I'm writing up to 5 decimal places. You can write up to maybe 2 decimal places if you want. So this is the equation of the tangent line. And you can see very clearly the slope is 0.5, which you got here. And when you go from left to right, the line is going up. That's why the slope is positive, which makes perfect sense. And also when you look here, The y-intercept is below the x-axis, which is negative. So we got the negative y-intercept. So this makes perfect sense. So that is how we can find the equation of the tangent line. In order to find the equation, we need the point and the slope. Point, we plug in the x value, we got the y value, that's the point. Slope, we use the concept of the instantaneous velocity to calculate the slope here. And once we have the point and slope, this is the formula to calculate the equation.